welcome to BotBros. Today we'll be mastering object-oriented programming in Python. So by today's lecture, we'll be able to understand core concepts of OOP, work with class and objects, use encapsulation, inheritance, polymorphism, and implement real-world AI-based OOPS project. So what is OOPS exactly? So if we go by the definition, OOPS is a concept that refers to programming language that uses objects in programming. So to understand what exactly OOPS means, let's go to our chapter 1. Why OOPS important for AI? Object-oriented programming is a powerful programming paradigm that makes AI applications scalable and modular. Used in machine learning frameworks, makes code more reusable and efficient, helps build AI models with real-world objects and behaviors. So if we go to classes and objects, probably we'll be able to understand the concepts much clearer. So let's take example directly to understand. Car is an object and car has multiple attributes such as weight, color and method such as drive and brake. A class is like an object constructor or a blueprint creating objects. So let's begin our day 5 by directly going to our Python console and writing our first program for the day, that is creating class and objects. So now to define a class, what you have to do is enter the keyword class, write the class name, and here in definition, we use a constructor called init. And this can be given any values, for example, a self, a name, and skills. So what self exactly means is referring to an instant. That means self dot name equal to name, and then self dot skills equal to skills. So this means that the self is referring to the particular private values that is present inside the constructor. Now inside the class, let's define another function called as intro and define the self here as well when we are calling it. And then return a formatted string using f stating hey, whatever the name is, self dot name, and then you have self dot skills. So what this returns is whatever the value we enter from the object created. So now let me directly show you how to create an object. So if you just say student equal to the class name, that is BotBros, and then say the name is Alex and he is excellent in Python. Now I just print student dot intro, which here you can see here I've created the object. Just mention where exactly the object is. Okay, now if I run this will say bound method botbros.intro main object at this level. So what exactly this error means that we are missing a open bracket somewhere in our code. Were you able to find that out? That was during the function call, we had missed the brackets. So now if you run this, it'll say, hey Alex, you have Python skills. So here you can observe that we have created a class and here we have created the object and we are calling the function intro. So how this process works is this doesn't execute first. It comes outside the class and check for the main actually. And here student equal to BotBros. BotBros is the class name and we are initiating Alex and Python to be passed to our class. So once we call the function from here, it will directly go to self, and in self it doesn't have any values. So it will go to the constructor In constructor, it will assign self.name as name and self.skills as skills. And then when it comes to return, it will put the values of name and skills and give it to our print statement, which will print the values. So this here defines the class and the objects. Once we've understood what exactly the class and objects are, we'll be able to easily understand encapsulation. So what is data encapsulation? Encapsulation is a term that is frequently used in the programming language to make sure that you cover up something over another. So if I have to show you the program, here you can see that here you have a class and encapsulation hides data from direct access, keeping it safe. So encapsulation ensures that the original data doesn't get affected because of the caller function, so that in day-to-day life we have multiple codes of lines, and if by chance anything happens, nothing should happen to the main code. So if you can see here, I'll just show you another example for encapsulation. It will be the same class AI models, and then defining an in constructor using init function, and then self comma model, and then we say self dot model equal to model. Define, let me come out of the define the particular constructor and give a new definition or a function. So here we say get model and say self, and we give return self dot model, and outside the class in the main we will do is AI equal to AI models, that is the class name, and that will have the value of anything chat. Let me just give it GPT 4. Oh, okay. And then I'll just print this AI dot get model. So now if I run this, it'll give me GPT-4. So what exactly we are doing is this here may look similar to this, but here what we are doing is encapsulation. So this definition init self comma model is a private class, and this can be accessed only from the other functions present in the class and nothing outside it. So to ensure that only the particular private class is present, we will do an encapsulation of the particular function or maybe the constructor. Now we have understood what is encapsulation as well. Let's directly jump into inheritance. So what we do exactly in inheritance is calling a parent function from a child function. So this is a very easy concept where you have parent and a child. A child will call the parent from inside the child class to the parent class. So now let me just give a quick example for inheritance. I'll just mark it as inheritance. Here I say class parent, definition, define a constructor, same, let's give it a self comma model, and then define self dot model equal to model, and then return self dot model. So now here we have created the parent class. Create a child class. I'll just mark you where exactly we created. Here we'll create a child class. So class child, which will inherit the data from the parent, and then just define this by saying it's a child. So now here we can actually define another function name as parent c, and then just return self.model, and here in child c, that means class, we will just take as self and then return formatted string self dot model response. Okay, so self dot child, let's keep it self dot child, and let's give a formatted string for this as well to understand that this is being called, the parent is being called. Okay, this I'll leave it as parent. Here we'll keep it as self, and now the only part left is to call the child function from outside all the classes. So I'll just put bot child bot equal to, let's give it as child, and then say AI chatbot, and say print bot dot parent, and then we can print bot dot child. So now if we run this, we will get the output as not an error. The error is because child object has no attribute to the parent. So I'll give you 3 seconds to understand what exactly the problem was. So the error that was present was we were calling the class, but you're not supposed to call the class, but call the functions present in the class. So now if we rerun this, it will give us the desired value. The only mistake that what we had done was calling the class directly instead of calling the function. Here we give the object bot a child, and then the child is taking all the data from the parent class as well. So this here is called the inheritance. So as we understood inheritance, let's go to the next topic. That is polymorphism. So what exactly polymorphism means, that we will have the same function name present in both the classes. For example, here you can see that process, and here also you can see process. So now let me run a code to show you how exactly polymorphism works. So I just say polymorphism and just give a sample class text AI, and this will have a definition of process, and that has self. So now let's return a formatted string of anything, self, or just say processing data, right? And now if we define another class of image AI and give the same value, a def of process of self, and then this also will return formatted string of processing image, right? So now once we have initiated both the polymorphism functions, remember that both should have the same name. Now let's create an object called as AI models. So this will have both the classes present in them. So first it will have text AI, which will be initiated, and then it will also have image AI, which will be initiated. So now if we have to run, just put a for loop saying for model in AI models and then print model dot process. So what exactly do you think will happen? Will it give us an error or will it run it? Let's run it and check what exactly happens. So now if we run this, it'll say processing data and processing image. This means that whichever we have initiated first, that is text AI, will be called by the object, and then later on the process will be called for the image. If I replace these both and just make it image AI comma text AI, then if I rerun this, you can see here process image and processing data. So this process is called a polymorphism which has same function name and can be called with just one caller. So the value what we are initiating will decide which class has to be called. So this has many types and this usually helps us primarily to use AI agent that handles multiple data types. So now we have learned all the part 5 of day 5. Now let me go to the challenge. And the challenge for today is building an AI assistant class. Objective is to create an AI assistant that greets user, performs basic tasks, user inheritance, and then expected output says, hello, I am your AI assistant. Ask me a question. What is Python? So AI is Python, a programming language. So this has to be your task for the day or the challenge of the day. Until the next video, we'll see you soon. Bye.